Hello everyone, this is Pure Mathematics Chapter 1. So in this video we are going to discuss about the section 1.9, which is about quadratic functions and their graphs. So let us look at the definition of the quadratic function. A function f from real numbers to real r to r is called a quadratic function if f is defined by fx is equal to ax square plus bx plus c, where a not equal to 0 and a, b, c are any real numbers. That means any second degree equation which contains x square and x and c, the constant, whereas the x square quotient is not equal to 0. That means the equation must contain the x square terms, and b and c are any real numbers, and even you can take 0 also because they are any real numbers with no specific condition on b and c, but a, the quotient of x square, should not be 0. So any second degree equation of this type, ax square plus bx plus c, is called a quadratic equation. And here the important point is that the quotient of x square should not be 0. So let us take this example, fx is equal to 3x square minus 2x minus 1. So this is clearly a quadratic equation because if we compare with this general equation, a equal to 3, which is non-zero, x square quotient, and b equal to minus 2 and c is minus 1. You have x square term, x term and the constant. At the same time, the quotient of x square is not equal to 0, which is 3. X square quotient is 3, which is not equal to 0. So only condition is that one. It should be of the form ax square plus bx plus c, where the quotient of x square not equal to 0. So any such equation we call a quadratic equation. Let us take another, fx equal to minus x square minus 1. So is this a quadratic equation? Again, if we compare with this standard equation, ax square plus bx plus c, a we get a equal to minus 1. Quotient of x square is a, which is minus 1 here, and minus 1 not equal to 0. And what is b? B is 0 because there is no x term in this equation. That means x quotient, which is b, is 0. And c, the constant is c is minus 1. So a is minus 1, b is 0 and c is minus 1 if we compare this equation with the standard equation. So since the quotient of x square is not equal to 0, this is also a quadratic equation. Let us go to another equation, fx is equal to x square. It has only x square terms, no x term, no constant term. So is it a quadratic equation? Again, yes, it is a quadratic equation because if we compare with the standard equation, x square quotient a, which is here 2 is the x square quotient, which is non-zero, not equal to 0. And what about x quotient? Since there is no x term here, the x quotient is 0. There is no x term, tells that the x quotient is 0. And what about c? C is also 0 because there is no constant term. So this is again a quadratic equation with a equal to 2, which is non-zero, b is 0, b value is 0, and c is again 0. So these are the three examples of quadratic equations, and here you have only x terms, x square terms, 2x square, only x square term. This is a quadratic equation. You may have x term or constant, doesn't matter, but x square is must. So this is a quadratic equation only having x square terms, and this is again a quadratic equation which has x square terms and constant, no x term. This is also a quadratic equation. And if we look at this one, it has all the three x square terms, x terms and constant, and x square quotient is not equal to 0. This is also a quadratic equation. And if we look at the last equation, fx is equal to minus 2x minus 1. And if we compare with the standard equation, x square quotient here will be 0 because there is no x square. That means x square quotient is 0. But from the definition of quadratic function, x square quotient should not be 0. But here x square quotient is 0. There is no x square. Therefore, this is not a quadratic function. Okay, and since what is the reason? A equals 0, that is the quotient of x square is 0. Therefore, this is not a quadratic function. So quadratic function is always of the form ax square plus bx plus c, where the quotient of x square not equal to 0. That means x square term should be there. Without x square term, we cannot call it as a quadratic function. And x terms and constant are optional, like they may, sometimes you may have the x terms, sometimes you may not have x term, sometimes you may have the constant, sometimes you may not have. So it is not necessary that the function should have x and constants, but it must have x square terms, then only it is a quadratic function. So any quadratic function is of the form ax square plus bx plus c. This we must remember, this standard form. Now let us go to some remarks here. The domain of quadratic function is the set of all real numbers. That means for the quadratic function ax square plus bx plus c, the x values, the domain means x. So what x values you can take here? You can take any x value from the real numbers. That means you can take positive real numbers, you can take real numbers, negative real numbers, you can as well take 0. Any value you can take for x from the set of real numbers. So x can be positive real number, x can be negative real number, or x can be 0. That is the meaning of domain of this quadratic function is R. That means x belongs to R. Now coming to the graph of the quadratic function. So the graph of quadratic function is always a parabola. This kind of shape, if we observe this maroon color curve, this is the shape of the parabola, and this parabola is either upwards or downwards. So like this in the first curve diagram, or like this as downwards. So how do we know when it will be upwards, when it will be downwards? It all depends on the x square coefficient A. So if A is greater than 0, the x square coefficient A is positive, then the graph is upward parabola like this. And if A is negative, that is x square coefficient, that is A, if it is negative, then the parabola will be downwards U. So either the parabola is upwards or downwards depending on the x square coefficient, which is A here. So A greater than 0 upwards, and A less than 0 negative, it will be downwards. And this point is called the vertex of the parabola. So what is this point? This is the point where the parabola changes the sign. So here it is coming downwards up to this vertex. After that it is going upwards. So it changes the direction at this point. So the point where the parabola changes its direction, we call it as the vertex. So this is the vertex here. Here in this graph, in this diagram, this is the vertex. This point is the vertex where it is changing its direction. Up to this vertex, it is increasing. After this vertex, the curve, the parabola is decreasing. So it changes direction at this point. So that point we call it as vertex. And this is called axis of symmetry. This axis is called axis of symmetry. So what is the axis of symmetry? It is a line about which the curve will be symmetric. So if you observe this curve, so whatever we have the left hand side of this axis, the curve onto the left hand side of the axis is repeated on the right hand side of the axis. That is, we say it is symmetric about this axis. So the axis is in the middle of the curve, and about this axis the curve is reflected about this curve, the line. So this line we call it as axis of symmetry. So about this axis of symmetry, the curve will be reflected. So whatever we have to the left hand side of the axis, same will be repeated or reflected on the right hand side of the axis. So this is called the axis of symmetry. So for the parabola we have 3 points here. Either it is upwards or downwards depending on the x square coefficient a, which is a here. If a is positive upwards and a is negative downwards, and the other 2 points are that parabola will have one vertex where the parabola changes its direction, the point where it changes direction, and we can find the axis of symmetry. The line axis of symmetry is a line, this line, about which the curve, the parabola curve is reflected. Now these are the 3 points. Let us go to some other observations here. So let us take the standard equation fx is equal to ax square plus bx plus c equals 0. So this is the standard quadratic equation which is representing always a parabola. A quadratic equation is always a parabola of this type, either upwards or downwards. And a should not be 0. As we have seen before, quadratic means x square quotient should not be 0. It is not equal 0. Not equal 0 means either it is greater than 0 or less than 0. If it is greater than 0, the parabola will be upwards. If it is less than 0, downwards. So let us take the case when a is positive, that means upwards. Now if the parabola has only x square terms, no x term, no constant, like this, fx is equal to x square, only x square terms, this is also a parabola. This is a particular case where b is 0 and c is 0 and a I took as 1. So that kind of parabolas where it will have only x square terms always passes through the origin, and this origin will be the vertex. Vertex is at the origin. If the parabola or the quadratic function has only x square terms, whenever the quadratic function has only x square terms, it is a parabola where the vertex is at the origin. Origin is the vertex. Next case, if the quadratic equation has x square terms and constant but not x values, there are no x terms, only x square terms and constant term, like this, x square plus 1, then the parabola will have vertex on y-axis at some point on y-axis, not at the origin, other than the origin, at some other point on the y-axis, when it has x square term and constant but without x, no x term, b is 0 here. So in that case the vertex will be on the y-axis, not at the origin. Now the third case, if the quadratic function has all the 3 terms, x square term, x term and constant, all the 3, then the vertex will be neither at the origin nor on the y-axis. It will be at some other point other than the origin, other than some point on the vertex. So we can say vertex is neither on x-axis nor on y-axis. Here in this case, first case, when it has only x square terms, it is at the origin. Vertex is at the origin. That means it vertex is on the x-axis, on the y-axis, because origin is intersection of x-axis, y-axis. So vertex is at the origin, therefore vertex is on x-axis and y-axis. Whereas if it has only x square and constant, no x terms, then the vertex is on y-axis, like here. Vertex is on y-axis. And if we have all the 3 terms, x square and x and constant, then the vertex will be some other point, that means not on x-axis, not on y-axis. Neither on x-axis, we can say like this, neither on x-axis nor on y-axis. These are the observations. Now let us go to one example. Fx is equal to x square. We can write it as y equal to x square, because fx is nothing but the image. Image generally we denote it by y. So x values represents the domain and y values the image. Image of x, fx we can write it as y. Fx and y simultaneously we use for the same image. Fx we can write or y equal to x square. So as we have seen before, if the quadratic equation or quadratic function has only x square terms, then the parabola passes through the origin will be the vertex. Now is it upwards or downwards depending on this x square coefficient a, which is positive or negative. So here a is 1, x square coefficient a, which is positive greater than 0. So the parabola is upwards like this, and the vertex is at the origin. So whenever there are only x square terms in the quadratic function, it always passes through the origin. That we have observed before. And what is the domain of this quadratic function? Already we have seen for any quadratic function the domain is R. That means all real numbers you can take for x. X may be any real number, positive or negative or 0. Now the range. So here if you observe the range means y values. What are the y values? X may be any, both positive, negative or 0 real numbers for x. But y values, if you observe, y values are starting from here 0 and it is going to infinity on either side. When x is going to infinity, y is going to infinity. When x is going to minus infinity also, y is going to plus infinity. So in what we observe, y values are starting from 0 to infinity. Y values. We don't have negative y values. Y takes here for this curve, y is only always positive from 0 to infinity. Therefore, the range means y, the images. Range is from 0 to infinity. And the vertex, as I told, the vertex is at origin 0, 0. And the curve is decreasing when it is increasing. That means for what values of x the curve is decreasing, and for what values of x the curve is increasing. If you observe, when x is from minus infinity to 0, the curve is decreasing. The curve means y. The curve is decreasing for x is changing from minus infinity to 0. Now after that, when x is changing from 0 to infinity, okay, the y values are increasing. Therefore, how you can say the curve is decreasing in the interval minus infinity to 0, close to 0. So these are the x values for which the curve is decreasing. Curve means y. Y is decreasing or the curve is decreasing for these x values from minus infinity to 0. And the curve is increasing in which interval? When x is going from 0 to plus infinity. So from 0 to infinity, you can correct it as here closed 0. You can write it as closed 0. Closed 0 to infinity. From minus infinity to 0, it is decreasing. From 0 to infinity, it is increasing. That is about increasing, decreasing of the curve. Next, the curve has no maximum because the y values are starting from 0 to infinity. They are going to infinity. There is no maximum. And it has but the minimum. The curve has minimum. That means y values are some minimum at some value of x. So here this is the minimum value of y. After that it is going to infinity. So what is the minimum value of y? Is 0. And when we have the minimum value of y when x is equal to 0 at this point, at the vertex it has the minimum. All other y values are going to infinity. So the minimum value of y is 0 and we have this minimum value when x is equal to 0. So the minimum is at x is equal to 0 and the minimum value of y is again 0. This is the y value when x is equal to 0. So looking at the origin, we can find the minimum value here of y. Minimum value of y is 0. It occurs when x is equal to 0. Now we go to the next one, axis of symmetry. What is the axis of symmetry here? This line is called axis of symmetry. What is this line here? This is in fact the y-axis. Because 0, 0, the origin is the vertex, y-axis is the axis of symmetry, and the parabola is extended on either side of the axis of symmetry. So this axis of symmetry is y-axis, and we know equation of y-axis is x equal to 0 because on y-axis x always is 0, x coordinate. Therefore, the equation of y-axis is x is equal to 0, which is the axis of symmetry. So for any parabola we can write all these points. The domain which happens to be real numbers always, domain of quadratic function always real numbers, and you can write the range or vertex when the curve is increasing, when the curve is decreasing, and if it has maximum or minimum, and if it has maximum, what is that, if it has minimum, what is that, and what is the axis of symmetry. So we made all these points for this fx equal to x square. Similarly, we can take fx is equal to minus x square. So this curve or this function, quadratic function, also has only x square terms. So it passes through the origin again. The vertex is at origin. But the fact is that a, which is minus 1 here, the quotient of x square is a, which is negative, less than 0. So the parabola is downwards. Like this, the parabola is downwards u. Therefore, we can take all these points again. The domain is R. For any quadratic function, domain is R. This is fixed. And the range means y values. So what are the y values we are getting here? If we look at the graph, y values are from minus infinity to 0. There are no positive y values. Y values are negative infinity to up to 0. So the range is from minus infinity to 0. And the vertex, already we have pointed out, the vertex is at 0, 0. And the curve, when it is increasing and when it is decreasing. Let us see here, for what values of x the curve is increasing. For what values of x is on x-axis. The image y is on y-axis. So for what values of x the curve means y is increasing, and for what values of x, y is decreasing. If you observe, from x is from minus infinity to 0, the curve is increasing. And when x is from 0 to infinity, the curve is decreasing. So we can write that the curve is increasing from minus infinity to 0. That means for these x values, the curve is increasing. And the curve is decreasing from 0 to infinity. That means for the values of x between 0 to infinity, the curve is decreasing. And the curve has here, it has maximum, no minimum, because y values are going to minus infinity, negative infinity. So no minimum value, but there is a maximum. So it has a maximum value, no minimum. When it has maximum value at this origin, this is origin. So the maximum value is y equal to 0, and it occurs when x equal to 0. So the maximum is at x equal to 0, and the maximum value of the function y is also 0. This y value is 0 because this is the origin 0, 0, just like here. This is the origin, but it is the maximum value here because it is upward, downwards. It has no minimum, it has maximum value, which is 0, occurs when x is equal to 0. So, and the last point, the axis of symmetry. Just like previous case, so the curve is reflected on either side of the y-axis. This is y-axis because this is the vertex 0, 0. What is the equation of y-axis? X is equal to 0. Therefore, axis of symmetry is x equal to 0. Let us go to the other example. As I told, this example fx is equal to x square plus 2 has x square terms and constant term. The previous example we have seen only x square terms where the vertex passes through origin 0, 0. But here in this example, the quadratic function has x square terms and constant term. Therefore, the vertex is on y-axis. If you observe, the vertex is on y-axis. So how to find the vertex here? If we put x is equal to 0, because y-axis, the point if we want to find, put x is equal to 0. Y-axis equation is x equal to 0. If we put x is 0 here, fx, that is y will be equal to 2. So the parabola passes through the point 0 to x0, y2. X is 0, y2. That will be the vertex. Now, is it upwards or downwards? That depends on the x square quotient. What is x square quotient here? A, which is 1. 1 is greater than 0, positive. Therefore, the parabola is upwards. So it is upwards and the vertex is at 0, 2. So this 0, 2 how do we find? Because the parabola has only x square and 2 constant and x square terms. As I told, if you remember, if it has x square terms and constant, the parabola has vertex always on y axis. So to get that point, we put y equal to x equals 0 because y axis equation x equals 0 and we get y is 2. So once you get the vertex, the other points we write one by one and we know it is upwards. These are the two important points. Now the vertex is 0, 2. The domain always for quadratic function it is R. So x values you can take any real number, that is the meaning of domain is R. And the range, here if you observe the graph, the values of y are from positive infinity to up to 2. So the values we have for y values, the curve, are from 2 to infinity. 2 is the minimum. After that it is going to infinity on either side. So what is the range? Range means y values, images. So y values are starting from 2 to infinity. That is the range. Now increasing and decreasing. For what values it is decreasing, for what values it is increasing. If you see, when x is from minus infinity to 0, here x is 0, x is from minus infinity to 0, the curve is decreasing. So and when x is going from 0 to infinity, y values are increasing. So the curve is decreasing. For what values of x here? From minus infinity to 0, y is decreasing, the curve is decreasing. And the curve is increasing. For what values of x? From 0 to infinity, the curve is increasing. Y is increasing when x is from 0 to infinity. That is here, increasing in 0 to infinity. And this curve has no maximum because y values are going to infinity. There is no maximum. But the minimum value of y is there. We have the minimum value. Y values are from 2 to infinity. All values are more than 2 going to infinity, but the minimum value we have. So it has minimum, and what is the minimum value of the curve or y? The minimum value of y is 2 and it occurs when x is 0. So that we write here, the minimum is at x equals 0 and the minimum value of y is equal to 2. And again, axis of symmetry. So since the vertex is on y-axis, the curve is symmetric about y-axis. That is, it is reflected on both sides of y-axis. So axis of symmetry is nothing but y-axis, and the equation of y-axis we know x equal to 0. So the axis of symmetry is x equal to 0. Now let us go to the similar case with negative x square quotient negative. So we can write the same way. It has x square terms and constant term. Therefore, the vertex is on y-axis. As I told before, x square terms and constant means always on y-axis. And if we put x is 0, y will be 2. So the vertex is at 0, 2. But here only difference is x square quotient is negative. So the parabola will be downwards. The parabola is downwards and the vertex is at 0, 2. And all other points we can write. The vertex is at 0, 2. The domain of quadratic function always are all real numbers. And the range, if you observe the graph of this parabola, y values are from minus infinity to up to 2. Okay. Here observe, y values are all starting from minus infinity to up to 2. So the range is minus infinity to 2. And when the curve is increasing, when the curve is decreasing, you can observe here, curve is increasing. For what x values? From minus infinity to 0, it is increasing. And from 0 to infinity, for x values from ranging from 0 to infinity, y is decreasing. So the curve is increasing from minus infinity to 0 and decreasing 0 to infinity. And as we have seen, the curve has no minimum. It has maximum here. So what is the maximum value? Is 2. It has no minimum because it is going to minus infinity, the downside, downwards. So it has no minimum and it has the maximum only, and the maximum value of y is 2. And where it occurs when x is 0, y is maximum 2, its value is 2. So we can write maximum value of the curve or the parabola is at x equals 0, and the maximum value is equal to 2. And as we have seen, the axis of symmetry is again y-axis because the vertex is on y-axis. The symmetry, axis of symmetry is on y-axis. So its equation is x equal to 0. So all these points we can write for any given quadratic equation which is a parabola. Now let us look at the properties of quadratic functions and their graphs. So the general form of a quadratic function, as we have seen before, any quadratic function must be of this form: fx is equal to ax square plus bx plus c, where a not equal to 0. This is important. X square quotient should not be 0. Then only it will be a quadratic function. And that quadratic function we can write in the standard form: fx is equal to a times x minus h whole square plus k. So any quadratic equation ax square plus bx plus c can be written in the standard form. This is the standard form to find the vertex. That's why you must remember this. This ax square plus bx plus c can be written as a times x minus h whole square plus k. We can write this equation in this form by computing h and k. We have a, we have x, we need to find h and k. So here the values of h and k are given. H is nothing but h is equal to minus b over 2a, and k is c minus b square over 4a. So using a, b, c, x square quotient a, bx quotient b, constant c, using a, b, c, you can find h, which is minus b over 2a, and k, c minus b square over 4a. So if you get h and k, then the other points we can make here. So the general properties of quadratic function and their graphs are: the vertex of this quadratic function, the parabola, is at the point hk. That is the advantage of this finding hk. So once this equation is written in this form, if an equation is written in this form, then hk will be the vertex. This h as x coordinate and this k as y coordinate, then hk will be the vertex of the parabola. And if it is given in this standard form ax minus h whole square plus k, directly you can pick what is h and what is k. If it is not in this standard form of the parabola, then we have to get h and k from ABC using these two formulas. H is minus b by 2a and k is c minus b square over 4a. Now the next one, axis of symmetry for this parabola will be x is equal to h. So vertex we have hk, then axis will be x is equal to h. Whenever you get hk, you take this h, and the axis will be, axis of symmetry will be x is equal to h, which is a line parallel to y-axis. Always this x is equal to h is a line parallel to y-axis. And next, the parabola has either maximum or minimum. So if h is equal to k, the y value will be k. That will be the maximum or minimum. Here minimum value if a greater than 0. If a is greater than 0, as we have seen before, the curve will be upwards u. Therefore it has the minimum value. So what is that minimum value will be? This k, the y value is k. Where it occurs? When x is equal to h. That will be the minimum. And if a is negative, then the curve will be downwards. Therefore it will have maximum. It will have maximum if a is negative, because the curve will be downwards. And the maximum value will be then k. and it occurs when x is equal to h. Okay, and the last one, the domain of the quadratic function is always R, as we know, and the range always depends on this a. If a is positive, then the range is from k to infinity, because it will be upwards, parabola is upwards, therefore it has minimum value k, so the range is k to infinity. And if a is negative, the parabola will be downwards, therefore it has maximum value k, therefore the range is minus infinity to k, that will be the range. So these are all the points we see one by one in the next example. But you must remember, if the equation is directly given in this a times x minus h whole square plus k, then directly you can pick h and k, which is the vertex. H and k, the point will be the vertex, and thereafter you can make all these points. If it is not in the standard form, if it is given like this ax square plus bx plus c, where a not equal to 0, then you can compute h and k, which is a vertex. H is minus b by over 2a, and k is c minus b square over 4a. Let us look at the example here. F is from R to R be the quadratic function defined by fx is minus 2x square minus 4x plus 8. So this has all the three terms, x square term, x term, and constant. So the vertex is on neither x-axis nor y-axis, somewhere else. And now we have to find all these vertex, axis of symmetry, maximum or minimum value, intervals where f is increasing, decreasing, range, and the graph. So for all these points, first you must find the vertex. So it is not in the standard form like a times x minus h whole square plus k. It is only ax square plus bx plus c form. So using a, b, c, we can find hk, the vertex. Let us see here, fx is equal to minus 2x square minus 4x plus 8. This is the given equation. If we compare with ax square plus bx plus c, then a is minus 2 and b is minus 4 and c is 8. We can find the vertex hk from this formula. H is equal to minus b over 2a. That is equal to minus b. B value is minus 4. We keep there, over 2 times a value is minus 2. And if we simplify, this will be plus 4 and this is minus 4 total. H will be minus 1. And k equal to c minus b square by 4a. This is the formula for k. And c value, c is here 8. 8 minus b square, that is minus 4 whole square over 4 times a is minus 2. If we simplify, you will be getting 10. So h is minus 1, k is 10. So the vertex is hk, which is minus 1 and 10. And thereafter, looking at x square quotient, we can see is it upwards or downwards. So here it is negative, a is negative, so the parabola will be downwards. And the vertex is at this point, minus 1, 10, which is not on x-axis, which is not on y-axis. It is somewhere where x is minus 1, x value, this is origin, x value is minus 1, and y value is 10. So this is the vertex, and the parabola is downwards because x square quotient is negative. Now the other points from this graph we can write. The parabola is downwards, we know, and the vertex is at minus 1, 10. So what is the range? Range means y values. So y values are minus infinity to 10. The maximum value of y is 10. All the other values are range going up to minus infinity. So the range is minus infinity to 10. So when the curve is increasing, for what values of x it is increasing? From minus infinity to minus 1 up to here. Up to here it is increasing. So what is x is here? X is minus 1 here. Therefore, the curve is increasing from minus infinity to minus 1. And after minus 1, it is decreasing. So the curve is decreasing from minus 1 to infinity. Minus 1 to infinity, it is decreasing. And the axis of symmetry, as we have seen before, axis of symmetry always x is equal to h. X is equal to h is the formula. And what is h is here? Minus 1. So x is equal to h, that is x is equal to minus 1. So this is a line parallel to y-axis. This is the axis of symmetry. This line is x is equal to minus 1. X is equal to h, general formula, and here h happens to be minus 1. So x is equal to minus 1 is the axis of symmetry. And regarding the maximum and minimum, the curve has maximum, no minimum, because it is going to minus infinity. So it has maximum. So what is the maximum value here? 10. And when it occurs, when we have the maximum value, when x is equal to minus 1. So the maximum, no minimum, it has no minimum. The maximum is at x is equal to minus 1, and that maximum value is 10. Y is 10, the maximum value when x is equal to minus 1. And we can find the intercepts as well. So these are the intercepts, x-intercept, and this point is y-intercept. So what we mean by intercepts, the curve where it is intersecting x-axis are called x-intercepts. The point where the curve is intersecting y-axis is called y-intercept. So to find these x-intercept and y-intercept, we have seen before the procedure. What is that? To find x-intercepts, you have to put y equal to 0, because equation of x-axis is y equal to 0. Therefore, to find x-intercepts, we put always y is 0 in the equation, and the curve or the quadratic function. And similarly, to find the y-intercept, we have to put x is 0, because on y-axis x is always 0, or equation of y-axis is x is equal to 0. So let us see here, to obtain y-intercept, we have to put x is equal to 0 in the given function. Y equal to fx is equal to minus 2x square minus 4x plus 8, given equation, given function. And you can write this fx as y, because the image fx we write it as y. Both are the same. So y equal to minus 2x square minus 4x plus 8. In that, put x is 0. If we put x is 0, this x square term, x term will be zeros. We will get y equal to 8. X is 0 implies y is 8. Therefore, what is the point where it intersects y-axis? This point. This is the y-intercept. This point is 0, 8. X 0, y 8. Now similarly, x-intercepts we can find. What are x-intercepts? We can find these by putting y equal to 0 in this equation. So let us put that one. Let us go to next slide. So to obtain x-intercept, we put y equal to 0 in this equation. Y is nothing but fx. Fx is 0. That means minus 2x square minus 4x plus 8 is 0. This is an equation. If we solve this equation for x, we will get 2x values. Using calculator, you can find this. X will be minus 3.2361 and x is 1.2361. These are the 2x values where y is 0. That means the curve is intersecting x-axis at these 2 points. So x-intercepts are when x is minus 3.2361 comma y will be 0, and the other x-intercept is 1.2361 and again y will be 0. So this is the procedure to find intercepts for the given parabola. So let us go to the next graph. So here if you observe in this example, find the graph of the function fx is equal to x minus 3 whole square plus 2. So this is not of the form ax square plus bx plus c. Rather it is of the form a times x minus h whole square plus k. This standard form. A times x minus h whole square plus k. So if we compare the given equation, fx is x minus 3 whole square plus 2 equal to a times x minus h whole square plus k, then a is equal to 1. The coefficient a will be 1, which is greater than 0. And h is equal to 3. If we compare, h is 3. And k is equal to 2. So we got hk, which is the vertex, and we got a is 1, which is greater than 0. So therefore the curve of the parabola is upwards because a is positive greater than 0, and the vertex is at 3 2 hk 3 2. So from this information you can write all the other points. What is important is to find vertex, and thereafter is it upwards or downwards. Here it is upwards since a is positive and the vertex is at 3 2. So let us try to write the other points which are domain. Domain is always R as I told. So the domain of the quadratic function is always R. Next, the vertex hk, just now we found 3 2. H is 3, k is 2. And the range, if you observe the y values are from minus infinity to 2. So the range is from changing from 2 to minus infinity. 2 is the minimum value, not minus infinity here, plus infinity. Y values are going to infinity, positive y. And the minimum value of y is 2. So how you can write the range? Range means y values starting from 2 to infinity. So 2 to infinity is the range. So the next one, increasing, decreasing. The curve is here, decreasing. So for what values it is decreasing? For what values of x? From minus infinity to 3. X is 3 here. X is 3. So from minus infinity to 3, the curve is decreasing. That we have written here, minus infinity to 3. And when the curve is increasing, from for what x values? From when x is from 3 to infinity, the curve is increasing. So the curve is increasing from 3 to infinity. And does it have maximum? No, because y is from 2 to infinity. It is going to infinity, y values. So there is no maximum. But it has minimum. Okay, what is the minimum value? The minimum value of y is 2. And it occurs when x is 3. So the minimum value of y is 2 when x is equal to 3. And the axis of symmetry. As I told, the axis formula always x is equal to h. X is equal to h. What is h is here? 3. So x is equal to 3 is the axis of symmetry. And around this axis, the curve, which is the parabola, is reflected. On both sides, it will be reflected about this axis of symmetry, which is x is equal to 3. So, and again, to find x-intercept and y-intercept. Here there is no x-intercept. Why there is no x-intercept? Because it will never intersect x-axis. That means y will be never be 0. Y never be 0. Y means this fx. For whatever you take x, y is never 0. Okay. So whatever you take x, it is always y. 2 or more than 2, y will be never 0. That means the curve doesn't intersect x-axis. So it has no x-intercepts. And to find y-intercept means you have to put x is 0 here. Y-intercept means y-axis. Y-axis means x value 0. If we put x is 0 here, in this, here it is written, to find y-intercept, put x is 0 in this equation or the quadratic function. If we put x is 0 here, minus 3 whole square, that is 9 plus 2. 9 plus 2 is 11. So when x is 0, y is 11. Therefore, what is the y-intercept? Where the curve is intersecting y-axis is the point 0, 11. X 0, y is 11. And are there any x-intercepts here? No. There are no x-intercepts, because for any x value, y is never 0. Y means fx. Y will be never be 0 here. That means it is not intersecting x-axis. So there are no x-intercepts for this quadratic function, which is a parabola. And similarly, you can take another. It is again in the standard form. Standard form, this example, fx is minus 2 times x plus 1 whole square minus 2. If we compare with the standard equation a times x minus h whole square plus k, a equal to minus 2. And h h is minus 1, because x plus 1 you can write it as x minus of minus 1. We have x minus h, this is the standard form. So h will be here minus 1, and k is also minus 2. So a is negative minus 2, therefore the parabola is downwards, and the vertex h is minus 1 and k is also minus 2, therefore the vertex is minus 1 minus 2. And now using this we can write all the other points. The domain is always all real numbers. It takes all x values, any real number you can take. That is the domain. Vertex is at hk, which is minus 1 minus 2. The parabola is downwards because a is negative, a is minus 2 negative. And the range, if you look at the graph, the values are going from minus infinity to minus 2. The y values are from minus infinity to minus 2. So the range is minus infinity to minus 2. And when the curve is increasing, for what x values it is increasing? From minus infinity to minus 1. This is the x value. And from minus infinity to minus 1 it is increasing. And after minus 1, when x is from minus 1 to infinity, y is decreasing. So it is increasing between minus infinity to minus 1 and increasing and decreasing in the interval minus 1 to infinity. And the curve has maximum. It has no minimum because it is going to minus infinity. So it has no minimum. It has maximum value. So what is that maximum value we have? Minus 2. Y is minus 2. Maximum of y is minus 2. And it occurs when x is equal to minus 1. So the curve has maximum value y equal to minus 2 when x is equal to minus 1. And the axis of symmetry. We know axis of symmetry is always x is equal to h. Here h is minus 1. So x is equal to minus 1 is the axis of symmetry. This line. This is the axis of symmetry. X is equal to minus 1. And to obtain the intercepts. So here also the curve doesn't intersect x-axis. This parabola doesn't intersect x-axis. Therefore, it has no x-intercepts, but it has y-intercept. So to find y-intercept, you put x equal to 0, because equation of y-axis is x equal to 0. So to obtain y-intercept, put x is 0 in this curve, in this equation of the quadratic function. We put x 0, so this will be 1 square 1 times minus 2, and another minus 2. That will be minus 4. So y is minus 4 when x is 0. So the y-intercept, where the curve, the parabola intersecting y-axis is 0, minus 4, x 0, y is minus 4, and it has no x-intercept because the curve doesn't intersect x-axis. And here we have few problems in the exercise. Function is given, which is a quadratic function. You can find all these points, whatever they are asking. And here if you observe, the curve or the function has only x square and constant. Not all the three terms, x square and constant. Therefore, the curve is on y-axis. The vertex is on y-axis. And one more point, since a is positive, it will be upwards. The curve parabola is upwards, and you can try to write all the other points. And the next second question, it has only x square terms. Therefore, the vertex is at origin. Only x square terms, vertex is at origin. And the a, x square coefficient a is minus 1 negative. Therefore, the curve will be, parabola is downwards. And using that, you can write the other points. Similarly here, hx is 9 minus x square. It has x square terms and constant. Again, the curve has vertex, the parabola has vertex on y-axis, not at origin, on y-axis, and it is downwards because x square coefficient is negative. And you can try to write the other points. In the last one, fx is given of the form ax square plus bx plus c. So here a, b, c are given. not in the standard form of a times x minus h whole square plus k. So in this case, you have to get h and k using a, b, c. A is minus 4, b is minus 4, c is 16. Using these a, b, c, you can find h, k with those formulas. H is minus b over 2a and k is c minus b square over 4a. Once you get h and k, you can find the other points. Since here the curve, the parabola is downwards as x square quotient is negative minus 4, which is less than 0. So the parabola is downwards, and you can find hk and you can write all these points that are required here, that are asked in the question. So this is all about the quadratic functions and the graphs. So this is the end of this presentation.